wake up. Hi there, it's me again, Teacher Melvin. In this video, we're gonna talk about comparing fraction. Comparing fractions is just means telling which one is bigger. Just like we use regular numbers, especially less than, greater than, or equal. But unfortunately, it's not easy to look just the number by telling which one is bigger, because the value of the fraction depends on the value of the number on the top and bottom. To understand better, I will show you a video that will tell you some methods in comparing fraction.
Hi there, welcome to Math Antics. In this video, we're going to learn how to compare fractions. This fraction has 25% more fiber than this fraction. Ooh, but this fraction has trisodium phosphate. Well, it's not quite like that. Comparing fractions just means telling which one is bigger. You know, just like we do with regular numbers when we use the greater than, less than, and equal to signs. That sounds easy, right? But unfortunately, unlike regular numbers, it's not always easy to tell which fraction is bigger just by looking at them. That's because the value of a fraction depends on both the top and bottom numbers and how they relate to each other. For example, if you have to compare these two fractions, 1 over 3 and 1 over 10, some of you might be tempted to say that 1 over 10 is bigger because you know that 10 is bigger than 3, right? But we need to remember that the fraction is really a number written like a division problem, and its value depends on that division. So in this case, the 1 over 3 is really the bigger fraction because its decimal value, what you get when you divide, is 0.33333. But the value of 1 over 10 is only 0.1. Okay, so comparing fractions isn't quite as easy as comparing regular numbers, but that doesn't mean it's going to be that hard. We're going to learn two methods for comparing fractions that make it very easy. The first method is called cross-multiplying, and it takes advantage of the fact that it's easy to compare fractions with the same bottom numbers. If two fractions have the same bottom numbers, then we can just compare the top numbers. That's because we're comparing the same size parts. We're comparing fourths to fourths, eighths to eighths, tenths to tenths, and so on. And the top number just tells us how many of those parts we have. So it's easy to see that 5/8 is more than 3/8. But many times you'll have to compare fractions that have different bottom numbers or different size parts. Fortunately, there's a trick we can do to make the comparison easy. In the Math Antics videos about common denominators, we learn a simple method for changing unlike fractions with different bottom numbers into like fractions with the same bottom number. Basically, it shows how you can multiply two unlike fractions by whole fractions made from the different bottom numbers, so you end up with the same bottom number. This will give you two new equivalent fractions that you can easily add, subtract, or compare. But there's a shortcut for comparing fractions. As long as we know that the bottom numbers of our fractions are the same, we don't really need to know what that number is. We just need to know what the top numbers will be, since those are the ones that we'll actually compare. So instead of multiplying each fraction by a whole fraction, we can just multiply the top number of each fraction by the bottom number of the other fraction. This is called cross-multiplying, because if you draw a diagram of what you're multiplying, it forms a crisscross pattern. After you cross-multiply, you'll have two numbers that would be the new top numbers if you had made like fractions, and those numbers will show you which fraction is greater. Let's try this cross-multiplying method on an example or two. Let's compare the fractions 7 over 8 and 4 over 5. We start by multiplying the second fraction's bottom number, 5, by the first fraction's top number, 7. And that gives us 35 for the new top number on this side. You'll always keep the answer on the side of the top number that you multiplied. Now for the other side. The bottom number, 8, times the top number, 4, gives us 32 for its new top number. Aha! Now it's easy to see that the fraction 7 over 8 is greater than the fraction 4 over 5 because its new top number, 35, is greater than the other new top number, 32. Let's do one more comparison by cross-multiplying. Let's compare 6 over 11 to 9 over 15. First, we'll multiply 15 by 6 to get the new top number of the first side, which is 90. Now you can always use a calculator to do the multiplications if you need to. Next, we multiply 11 by 9 to get the second new top number, which is 99. So that tells us that the second fraction, 9 over 15, is greater than the first fraction because its new top number, 99, is bigger. Pretty simple, huh? Okay, cross-multiplying's pretty cool, but there's another way to compare fractions that you need to know about. But this one's only really good if you can use a calculator. Remember, the reason that fractions are tricky to compare is because they're really division problems. But if we want to, we can just do the division and get the answer, which is the decimal value of the fraction. So if you have two fractions to compare, you can just do the division, preferably using a calculator, and then compare the decimal values. For example, let's say I offered to give you either 5/12ths of a pizza or 7/15ths of a pizza. Now you happen to be really hungry, so you want to choose the biggest amount. But it's not very easy to tell just by looking which is bigger, 5/12ths or 7/15ths. This is where decimal values can really help you out. If you convert the fractions to decimals by doing division, it will make it much easier to see which one's bigger. 5 divided by 12 is about 0.42, and 7 divided by 15 is about 0.47. Yep, that makes comparing them much easier. Since 0.47 is greater than 0.42, it means that 7/15ths is greater than 5/12ths, and that means that you'd rather have 7/15ths of the pizza. Sometimes, when you compare fractions this way, you'll find two fractions that look different but have the same decimal value, like 3 over 8 and 15 over 40. If you convert each fraction to a decimal, you'll see that they both have the value 0.375. Two fractions that have different top and bottom numbers but the same value are called equivalent fractions. If two fractions are equivalent, then you can just use the equal sign to show the comparison between them, like this. All right, so those are two great methods you can use to compare fractions. Cross-multiplying is simple and works great, even if you don't have a calculator. And comparing the decimal values by dividing is easy if you do have a calculator. As always, practice makes perfect. So spend some time doing the exercises for this section, and I'll see you next time. Learn more at mathantics.com.
Did you learn something on the video? I hope so. Okay, I have here another video that will show you another method of comparing fraction.
Welcome to Math with Mr. J. In this video, we're going to take a look at how to compare fractions. And as you can see, there are 4 comparisons on your screen, and we're going to go through each of these 4 in order to get this down. So let's jump right in to number 1. And for number 1, we have 3/8 and 13/16. So the first thing you want to do when comparing fractions, check to see if they have a common denominator. If so, it'll be pretty easy to compare the two fractions. If they do not have a common denominator, we need to find one and rename those fractions. That way, it'll make it very easy to compare when we do have a common denominator. So let's take a look. We have 3/8 and 13/16. So obviously we don't have a common denominator there, so we need to find one and rename. And the common denominator for an 8 and a 16 is 16. So let's rename this first fraction, and I'm going to do it underneath there where I wrote that 16. Well, I know 8 times 2 will give me 16. So in order to find an equivalent fraction, we need to do the same thing to the top. So 3 times 2 is going to give me 6. 3/8 is equivalent to 6/16. They hold the same value, so I did not change the problem. I just renamed with that common denominator. The second fraction, 13/16, already has a denominator of 16, so I do not need to rename or do anything to that fraction. Now that we have a common denominator, it's very easy to compare. And we can see that 6/16 is less than 13/16, right? 13 out of 16 is going to be greater than 6 out of 16. So let's put our symbol in here, and we can read that from left to right as 3/8 is less than 13/16. Another way to think of this problem is, you can see on the left we have 3/8, right? That's less than half, because half is 4/8. So the left side is less than half. Now on the right, we have 13/16, and that's greater than a half, because half of 16 is 8/16. So the right side is more than half, and the left side is less than half. So we could tell by using that strategy, or you can prove it by changing the denominators, using a common denominator and renaming. So let's take a look at number 2 here. We have 2/12 and 8/9. We do not have a common denominator, so let's find one and rename. So for 12 and 9, your common denominator is going to be 36. 12 times 3 is 36, so let's do the same thing to the top. 2 times 3 is 6. 9 times 4 is 36, so do the same thing to the top. 8 times 4 is 32. Now that we have a common denominator and we renamed, it's very easy to compare. 6/36 is less than 32/36. And let's take a look at the original problem again. Now, 2/12 is less than half, right? Because 6 out of 12 is half, so obviously 2 out of 12 is less than 6 out of 12. So the left side is less than half. And the right side, half of 9 is 4.5. And we have 8/9, so we're well over half. So the right side, right off the bat, we could see is more than half, and the left side is less than half. That can also help us compare. But again, we proved the comparison when we found a common denominator and renamed. So let's take a look at number 3. Now, both of these fractions are over half, so we can't use the benchmark strategy here with these fractions. So we're going to need to find a common denominator and rename. So 3/4 and 6/8. So we have a 4 and an 8. And our common denominator is going to be 8. Now that second fraction, 6/8, already has that denominator of 8, so we do not need to do anything. We're going to leave it as is. 3/4, okay, we need to think, well, 4 times 2 gives me that denominator of 8, so I need to do the same thing to the top. 3 times 2 gives me 6. So both sides are equivalent to 6/8. So both these fractions are equal. So 3/4 is equal or equivalent to 6/8. Let's take a look at number 4. And just using benchmarks and fraction sense, when I talked about the half for numbers 1, 2, and 3, that's a benchmark fraction that we can base different things off of. So when I say the word benchmark, I'm just talking about a fraction we can use to help us through these problems. Now 8/10 is above half, right? Because half would be 5/10. And on the right we have 17/20. Well, half of 20 is 10. So that one's above a half as well. So we can't really tell right off the bat which one's greater or less than. So let's rename with a common denominator. So we have a 10 and a 20. So our common denominator is going to be 20. Now the second fraction, 17/20, already has that denominator of 20. So we do not need to do anything to that fraction. Now the first one, well, 10 times 2 gives me the denominator of 20. So let's do the same thing to the top. 8 times 2 is 16. Now these fractions are very close in value, but the 17/20 is 1/20th greater. It's a little bit greater. So let's read this left to right. 8/10 is less than 17/20. So there you have it. There's how you compare fractions. Use benchmarks, right? Use half to kind of judge where you're at with the fractions, and then rename using common denominators in order to prove your answer. Thanks so much for watching. Until next time, peace.
Did you like the video? Or did you learn something? Okay, remember, there are different methods in comparing fraction. You can also make your own method, which you find easier to solve and understand. Okay, after this video, I will give you some worksheets to do at home. I think that's all for today, guys. I hope that you learned something on our discussion. See you again next time. Okay? Stay safe and stay home. Khop khun krap.